All right. Hit me with a question.
So in that last one,
Yeah.
there's only two X spots, but you wrote down 23 plus 3X. I thought there was two dashes, not three. So why is there 3X but not 2X?
Perfect question. So think about it. I have 23 here, and I have 5 all over here. 2 spaces. So to get from 23 to this space, I'm adding some number plus X. Then to get from this space to this space, I'm adding that number again plus X. But then to get to 5, I have to add X again plus X. So I'm moving 3 times. That's once, that's twice, that's 3 times. So going from 23 to 5 is 3 spaces. So 1, 2, 3. It's just the last space is the third space, and they already give you that number. You just got to find out what's going in between. Does that make sense? I'm here to help y'all. You see, that's what I'm talking about. Ask questions, because I guarantee you a question you have, at least one other student has it. So now here, these are basic examples of what you will see in IB math in terms of arithmetic sequences. What we just showed in that last warm-up was something called a common difference. That's the pattern. So the common difference is just another word for pattern. What that means is what's happening between these two numbers that are right next to each other. Sometimes we'll say adjacent numbers or adjacent terms. The way we find that pattern is what I know some of you did in the previous warm-up is you'll say, oh, I'll take these two and I'll just subtract. That's why it's called a common difference. I take one term and subtract the one right before it. So I'll say 22 minus 15. That gives me 15, 16, 17, 18, 19, 20, 21, 22. Don't be afraid to use your fingers. I do it all the time. Equals 7. So my pattern is 7. We'll say D equals 7, or difference. So if my difference is 7, what's my first term? Well, I go back another 7. So 15 minus 7 would be 8. So now this one, it looks confusing. Like, oh my God, what is all this? First we had good numbers, now we have this. Well, they're just trying to trick you. They want you to use the same exact knowledge we took here and apply it here. I'm going to take two terms that are adjacent or right next to each other and then subtract them. So it's going to be this one minus the one right before it. So it's 3x minus 1. So it's this whole thing, 3x minus 1 minus 3x minus 2. And I put those parentheses there for a reason, because you're going to see. So watch this. I do 3x minus 3x. Oh, wait, you're right. Sorry. I'm getting ahead of myself. It's plus 1. Thank you. So, okay. So it's 3x minus 3x, which would be 0, right? So I have 0 here. Then I have positive 1. Thank you, Jimena. Positive 1 minus negative 2. So then I have, what is 1 minus negative 2? That's going to be 1 plus 2, which equals 3. So if you look here, you see how it's changing each time? Negative 2 plus 3 is 1. 1 plus 3 is 4. So right, so then this has to be 3x minus 5 if you go the other way. So it'll just be negative 2 minus 3. Now see here, this part, this is like what I just showed you in the warm-up. Now let's see if you can figure out what the common difference would be here. Well, I'll just leave this here and say, okay, the first term is 44. So if this student got 44, what are the other two terms? So again, just to make sure we're on the same page, this is what this person did. They said, okay, look, I'm going here, that's 1, that's 2, that's 3, 4 times. So 30 plus some number 4 times, I don't know what it is, just 4x, equals negative 26. So if I just do some good old algebra, 4x equals negative 56. That's a 5. 56. Because I subtracted 30 from both sides. If you divide negative 56 by 4, you'll get x equals negative 14. So this is your common difference, or your pattern. So here you're just doing subtract 14 each time, and then add 14 to get this one. That's how you get 44 here. So when you see those spaces, don't get nervous. Just know that, oh, it's got to be the same pattern. It's got to be the same number each time. Exactly, slight. Thank you. Thank you. All right, so now, real quick, I just want to show you, this is what we're working with, our arithmetic formula, arithmetic sequence formula. We actually showed this before in the last two slides. It's just we didn't use this formula. We showed how it worked. So if I want to find, here it says find the 26th term. That's the nth term. If we want to find the 26th term, I say I need the first term first. My first term is right here, so that's U1. So first term, 0.1, and then plus n, the position of the nth term, it's 26. So 26 minus 1 times our difference. So remember, I can just take any two of these that are adjacent and subtract that from that, and I'll get 0.4. So my difference is 0.4. So I just use that formula now. I'll say the 26th term, U26, equals 0.1 plus 26 minus 1 times 0.4.
You'll go over how you fill in the formula again, please.
Yeah, I got you. I'm gonna do it over again. What they want from you is two most important things for this formula is they want the first term and they want that common difference, your pattern. So first, that's what I would look for first. So this is my first term here. This is U1. My pattern is I can take this minus that. So my D equals 0.4 because I subtracted those two. So now in this formula, those are the first things I actually always fill in. So I know something equals first term plus n minus 1, I'll say that for last, times the difference. Those are two easiest things to get, the difference or the pattern and the first term. So if I want to find what the 26th term of this sequence would be, I need to know, okay, put 26 here because that's the term I'm looking for. That's the 26th number in the pattern. So this is just all calculator. You just type this in. If you type all this in the calculator, you should get 10.1.